Hello, in this video, I will explain to you on how to solve this problem from Halliday's books number 15. An 11 kilogram salami is supported by a cord that runs to a spring scale which is supported by a cord hung from the ceiling, like this figure. What is the reading on the scale which is marked in SI weight units? So SI weight units is Newton, right? So let's draw the force that works on this salami here. This is the salami with the mass of 11 kilogram. So I have the mass of 11 kilogram here. And here we have the weight of this salami here, pulling it down, right? So let's name this as the force by the weight of the salami, okay? And then here I will have the rope here pulling this up, pulling this salami up. But also I have this rope here pulling the spring scale down, right? So we will have this here. And this is, let's name this as T1 here, because this is the one that read by this spring here, right? Okay. But that is the same as T1 that works from this here, so that pull up this salami. Okay, and because it is stationary here, we have the acceleration is equal to 0. So here the sum of the force in the x direction, no, not in the x direction, in the y direction, in the vertical direction, is equal to mass multiplied by acceleration, but that will equal to 0 because it is stationary, right? And then we will have this, what is pulling this up, I will have T1 here. And I will have what is pulling it down, the weight of the salami. And all of that will equal to 0. And let's plug the formula here. The weight of the salami is the mass multiplied by the gravitational acceleration. And that will equal to 0. Let's plug that in. I will have T1 minus the mass is 11. And then what is the gravitational acceleration? I will have 9.8 here. And all of that will equal to 0. So I'll have T1 minus, okay, what is it? 11 times 9.8. That will be 107.8. 107.8 here. And all will equal to 0. And let's move this. So I will have T1 here, which is the spring reading. So I will have spring scale reading. So I'll have 107.8. And then the unit here will be in Newton. Good. And I think that's all for problem A. Let's move on to problem B. Okay, here we have our problem B. So here, this is our salami here with the mass of 11 kilogram. And also we have 8 weights pulling down like this. So this is the force of the weight. And then this spring here pulling that up, right? And that will be, let's name that our T2 because T1 has already used. And because this is frictionless, and then this will push the spring there and it will read by that spring. So I will have T2 here, right? So what can we do is we need to analyze at this salami here because we need to find out what is T2 here. But T2 is the same as here, so we can just use this salami here as the analyzing point. So the sum of the force in the y direction, in the vertical direction, is equal to the mass multiplied by the acceleration. But that will equal to 0 because it is not moving or stationary. Okay, and let's plug the forces. I will have T2 here that pulling it up. And then I will have the weight of it pulling it down. So I'll have FW, and that will equal to 0. So we'll have T2, and then minus the mass of the salami, and then the gravitational acceleration. And all of that will equal to 0. So we'll have T2 minus the mass. What is the mass? I will have 11. And then what is the gravity? I will have 9.8. And all of that will equal to 0. And I think we will have the same value here. So I have T2 minus 107.8. And the unit will be Newton here, but let's isolate that first. So I'll have T2 is equal to 107.8 Newton. And that is the reading of the spring scale here. Okay, now let's move on to one more case, which is here, the spring scale. And okay, the wall has been replaced with a second 11 kilogram salami. Okay, so we will have these two salami here with the mass is 11 kilogram. Okay, so I will have the mass here is 11 kilogram. Okay, and both will have the weight pulling it down. So I'll have F weight here, and I also have the F weight here. It is the same, right? Because we have the same mass. Okay, and then we will have this one here. Maybe let's name this T3, and let's also name this T4. Okay, so we will have this force here. It is not going there, it is going to the left. So I'll have it is going to the left here, and that is T3, and I also have T4 going there. Okay, but we need to find out T4, right? Because this one replaced the wall, and the one that is reached by the spring scale is this one here, right? Remember, the wall is on the left here, and we need to read T2 here in the problem B. So we need to find out what is T4. So we need to do the analysis on this salami here on the right side. Okay, so I will have the sum of the force, but it is on the y direction here, and that will equal to the mass multiplied by the acceleration. But the acceleration will be 0 because it is not moving or stationary. Okay, now let's plug in the forces. I will have T4. Okay, and then I will have the weight pulling it down. So T4 minus FW, and that will equal to 0. And so we'll have T4 minus the mass of the salami multiplied by the gravity acceleration. And so I'll have 0 here. So we'll have T4 minus, and I will have 11 multiplied by 9.8 here, and all of that will equal to 0. So we will have T4 here minus 107.8 is equal to 0, or we can isolate it for T4, and T4 is 107.8 Newton. So we have answered all of the question, which has all the same answer, 107.8 Newton. Okay, and I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.